Hello and welcome to the 1.5 day 2 video. The last video was kind of long. It was just a lot of information thrown at you and I was only really able to go through one full problem. So today it's just all practice problems, not all of these. We're going to go through 4 of them. I'm going to let you know which ones we're going to be focusing on. So we're going to be going over this problem. Oh, that's not a highlighter. There we go. We're going to be going over this problem first. And the problem all the way down at the bottom, we're going to go over that one second. And then there's 2 problems like kind of in the middle that are almost exactly the same here and here that are 3rd and 4th. And I wanted to go over those just show you that parentheses really do make a big difference. So again, this is our first problem all the way down here. That's our second problem we're going to do. Then here's our 3rd and 4th problem. I will be writing the equations at the top of the graph so you know which one we're working on, but I just wanted to let you know that there's, many different ones that I could have chosen from, and you can use these as practice problems. So let's move on. So like I said, I'll be writing the problems up at the top. So our first problem is g of x. I'm actually going to change the color of this. There we go. I say that g of x is equal to x minus 5 squared plus 1. So this is the first equation that we're going to be looking at. Now, I also need to say what is its parent function or the original function. If you take a look at GoFormative, I've left some graphs there for you. When I look at this, I go, okay, there's an x squared in this. So remember, the parent function is just what the function would be without any transformations. So based on this f of x here, what happened here? Well, I see we have a 5 and we have a 1. So now I'm going to list the transformations. What happened to g of x? Well, first I'm going to list my x values, and I see we have a minus 5 inside the parentheses. That's going to be a horizontal shift. Now, in the last video, I wrote out horizontal shift or vertical shift for all of these. I know that horizontal and vertical are just really long words. So if you want to write H shift, that is okay with me, as long as you are saying an H or a V, so we know whether it's horizontal or vertical. So this is a horizontal shift. Which direction? Since it's a minus 5, it means it's going to be moving to the right, and it's moving 5 units. So that's our first transformation. And the second part is that plus 1 at the very end. So that's going to leave us with a vertical shift or a V shift. The direction is going to be up, and it's going to be 1 unit. That's an I. Okay, so these are the 2 things that are happening. Let's graph both of these functions, and it told us to check our work by making a table. I'm going to be making the table as we move along, so let's get started. So let's start with just our regular parent graph. Now for x squared, we're going to be using the x values from -2 to 2. And this is going to help us graph our parent function as well. So if I plug in all these x values into x squared, I'm going to get 4, 1, 0, 1, 4. And on my graph, I know the graph is not scaled. I'm just assuming that everything on both axes is scaled by 1. And then for good measure, you know what I'm going to add? You don't have to add these extra points. I'm just doing it because I am not the cleanest drawer, and so having extra points really helps me. Okay, so that is my f of x. Make sure that you label. Excellent. But then what's happening? So first we have a horizontal shift to the right 5 units. So that's going to affect our x values. So for my x values, I'm going to add 5 to all of them. So if I do that, this becomes 3, 4, 5, 6, and 7. These are all my new x values. And then my last transformation of vertical shift moving up, that's going to happen to all of my y values. So I'm going to add 1 to all of the y values. And it's going to leave me with the values of 5, 2, 1, 2, and 5. And these are going to be my new y values. So now that I've made my table, I know what all my values should be. Let's move over. So let's see, that's going to look 3, 5. That'll be right there. 4, 2, 5, 1, 6, 2, and 7, 5. So it's going to look something, oops, like that. See, again, not the cleanest drawer. And we'll label that with g of x. So this is what a full problem looks like. This is what I'm looking for from you. This problem may be a little bit simpler than others because there's only 2 transformations and they are both shifts. But what if we moved on to something a little bit fancier? Let's take a look at that very last problem on the page, or what we're going to call problem number 2. So let's take a look over here. So let's see, for us, now we're going to have g of x is equal to 4 times the square root of 2 times x plus 1 plus 3. Isn't that a beauty? And I look at this and I go, okay, what is my parent function? We're only going to be dealing with a few different types of parent functions because we will be graphing with exponential and rational functions later on. So for right now, I can say, hey, my parent function, that is just square root of x. So if I take a look from here to here, a lot of different things has happened. We actually have stretches and compressions, both vertically and horizontally. I got a lot of shifts. So let's just focus in on the x's. So that's going to be right here underneath the radical, underneath that square root. And remember, I'm going to go in order of operations. So we're going to do multiply and then add. So my first, I'm going to move this up. There you go. My very first transformation is going to be a horizontal, or H, compression and I don't want you to just say by 1/2, I want you to say by a factor of. By a factor of 1/2, because if you remember from the last video, we're always going to multiply our x values by 1 over that b value. So this here is our b value. So it's going to be 1 over that b value, so in this case 1 over 2. Next I'm going to deal with that h value, or that plus 1. So my second step is going to be another horizontal, or h, shift. And since it says plus 1, we're going to move to the left 1 unit. So that's everything that we're dealing with horizontally. And then let's get to everything vertically, or with our y values. So next I'm going to go to my a, or my vertical, in this case stretch. And again, by a factor of. In this case, it's just going to be 4. With the y values, what you see is what you get. We don't have to do 1 over b or anything like that. So it's just 4. And then the last one, our k value, again, what you see is what you get. So it's going to be a vertical shift. Let's see, that's going to be up 3 units. So there's a lot that has happened here. Oh, there's an email. So there's a lot that's happened here, which means our table is going to be kind of big. So let's start on that table. Now, for this parent table, we're going to be using things that are a little bit different. If we used -2 to +2, well, first of all, you can't have the square root of a negative number, so you don't even have to worry about that. So let's start at 0. That's going to give us a value of 0. And then from here, it's going to make my life a whole lot easier if we just use perfect squares as our x values. Because if I plug in a 3 for, square root of 3, that's going to make things a little messy. So I'm going to use 0, 1, 4, and 9. That way we have 0, 1, 2, and 3 as our y values. So let's see, let's graph that. So it's going to be here, here. So it looks something like this. So this is our f of x graph. Now let's deal with our g of x. So first let's deal with those y values. First thing I'm going to do is I'm going to multiply everything by 1/2. And then my next step is to subtract 1 because of that shift. So if I multiply everything by 1/2, that becomes 0, becomes 1/2, 2, and 4.5. In this case, if you'd like to use 0.5, that's okay as well. And then if I subtract 1 from everything, I get -1, -1/2, 1, and 3/2. So these are my new x values. And then for our y values, first we're going to start by multiplying everything by 4, and then adding 3. So multiplying everything by 4, that's going to be 0, 4, 8, and 12. And then adding 3, that's going to be 3, 7, 11, and 15 for our new y values. Now, I am aware that this point here is not going to fit on our graph, and that's okay. Just fit the points that you can. We should hopefully be able to see the general shape that we're going for anyway. So if I was to graph my g of x, it would look something, let's see, so we have -1, 3, we have -1/2, 7, so like up here, and then we have 1, 11, so this only goes up to 10, so that's like here-ish. I'm kind of going slightly off the graph, and then we're not going to be able to fit the 15 in there. So we can tell that this really jumped up for our g of x, mostly because of that vertical stretch of 4. So this is showing you these graphs look vastly different because we've had so many more transformations. Hopefully you're able to remember a little bit from last year to follow along, because now I want to go over the 2 other problems that are so very similar but do look very, very different. So the third problem that we're going to go over today is g of x is equal to parenthesis -1/2 x, close the parenthesis, cubed. So when I ask, hey, what's the parent function? This has a cube in it, so we're going to say that's f of x is equal to x cubed. This is one of the other functions I'm expecting you to know. So I take a look at this and I go, well, what's the big deal with this parenthesis here? Well, this parenthesis means everything is happening to the x, or everything we have going on is horizontal. Whereas in the next one, where there's no parenthesis, it means it's not happening to the x and it's happening vertically, or to the y values. So inside parenthesis, that's happening to our x values. So the first thing I see, this negative here is separate from this 1/2 because it counts as a reflection. I don't care which order you list these in. That's totally fine. You just have to list them before any horizontal shift. So I'm going to start with the reflection. So it's going to reflect. Now remember, even though it's affecting the x values, it's going to reflect over the y-axis because that's where the switch between positive and negative x values happens. And then the second thing that happens is that there's going to be a horizontal, or h, stretch by a factor of 2. Because remember, we do 1 over that b value, and 1 over 1/2 is going to give us 2. So in this case, we're going to have a horizontal stretch. So let's see, let's make a table. Let's get this graphed. So first, let's get our parent graph situated. And this one, I'm going to be using the same x values that we do for x squared. So it's -2, -1, 0, 1, and 2. And then from there, -2 cubed is -8, -1, 0, 1, and 8. And the reason that we make these larger tables as opposed to just plugging things in is because that's not transforming, that's just plugging things in. We need to show the actual transformation and what's happening. So if I graph this, 0, 0, 1, 1, 2, 8, -1, -1, -2, 8, there we go. So our cubic graph is going to look like this. So that is our f of x. Then we have 2 things happening to our x values. So the first thing that's happening is we are reflecting, so we're multiplying by a -1. And then we're being stretched, so then we're going to multiply it by 2. So when we reflect everything or multiply it by a -1, it's going to become 2, 1, 0, -1, -2. And then when I multiply everything by 2, that's going to give us 4, 2, 0, -2, -4. So these are going to be our new x values. And then our y values, we don't have anything that's happening vertically, so we're just going to keep those exact same y values. So when I graph this, we're still going to have the point 0, 0. Let's see, and then we have the point 4, -8. It's going to be down here. I have the point 2, -1, -2, +1, -4, +8, all the way up here. So we can see that our graph has been flipped, and it's also wider, or is giving us that horizontal stretch. There we go. And giving us g of x. So this is what our transform graph looks like when all of this is happening to our x values, or is happening horizontally. But what happens if it's happening vertically? Let's take a look at our very last problem. So let's see, our very last problem, and again, I promise there is a difference, is g of x is equal to -1/2 times x cubed. So there's no more parentheses. The -1/2 isn't within the cube function. It's on the outside, meaning that this is actually our a value, not our b value. But mostly, that kind of everything else is the same. The parent function is still going to be x cubed. But now when I list the transformations of what's happening, we're no longer going to be affecting things horizontally. So step number 1, we're going to reflect, and now it's going to be over the x-axis, because if we reflect over the x-axis, that's the shift between positive and negative y values. And then the second thing is we're going to have a vertical or V stretch. Pardon me, not stretch, compression. I was looking at the other problem. Let me erase that. There we go. Compression by a factor of 1/2. Because remember, with the y values, what you see is what you get. So let's see. These are the transformations that are going on. Let's start by graphing our parent function. And this is going to be the same parent function as we had before. So I'm going to quickly make that table. We're going to be practicing these a lot, so hopefully you get a little bit more comfortable with them. Okay, so that's our f of x. And then from there, everything is happening to our y values. So first, we're going to multiply everything by -1, and then we're going to multiply everything by 1/2. Let's see, if I multiply all my y values by -1, I get 8, 1, 0, -1, -8. If I multiply them all by 1/2, I get 4, 1/2, or 0.5, 0, -1/2, and 4. So these are going to be our new y values, and then nothing happened to our x values, so all of these x values are going to stay the same. Let's see, so we're still going to have that point 0, 0. I have the point -2, +4. Let's see, -1, 1/2. We've got +1, -1/2, and 2. Oops, I dropped a negative. That should be a negative down there. 2, -4. There we are. So you'll notice that these endpoints, or these points we've been using, are actually different for this g of x than it was for our previous one. So make sure that you know the difference between what is happening to the function vertically, or with the y values, versus what is happening horizontally with our x values. If you have any questions, let me know. I look forward to seeing you at a later date.